friends, so after completing two numericals on inverse Laplace transform of logarithmic function or inverse tan function, let's start with another numerical. Here for you I've taken a different function and let's see how to find out the inverse Laplace transform of such logarithmic function. So here we have to find out the inverse Laplace transform of log of s square plus a square upon square root of s plus b. Now guys, since the given function is log function, we all know that whenever we have some log function or tan inverse function or cot inverse function, we cannot find out the inverse Laplace transform of such function by using the standard formulae. So to get the value of this, we are going to use the differentiation of phi of s property. Now that property has been derived from the multiplication by t theorem. So let's see that property first. So here you can see that by multiplication by t theorem of Laplace transform, we get the answer as negative d by ds of phi of s, and if I solve it on both sides, we'll get Laplace inverse of phi of s is equal to negative 1 by t Laplace inverse of phi dash of s. So what this property says, it says, let's say if you want to find out the inverse Laplace transform of any function of s, and let's say you are not able to get the answer directly, then that time you have to find out derivative of this and you have to find out inverse Laplace transform of its derivative. So it means the inverse Laplace transform of derivative must be possible. So that value will keep it here, we'll find the inverse and then we'll multiply by minus 1 by 10, we'll get the answer. So guys, remember that the inverse Laplace transform of the derivative of that function should be possible, and if let's say it's not possible, do not use this property because it is of no use. So let's start. So what I'll do is I'll call this function as function of s, I'll find out derivative of that, we'll find out the inverse Laplace transform derivative, and then we'll multiply by minus 1 by t. So now guys, what is derivative of this function of s? So don't be in hurry, don't try to find out the derivative of this log function directly, because here this function is again a complex function. I mean it's not in a simpler way. So what you have to do is you have to first apply the property of logarithm, bring it in the simple way, and then find out the derivative, because that time we'll get derivative in one step. So what is the simplest form of this log function? So guys, let's apply the property of log, which is log a upon b, and that is equal to log of a minus log of b. So here we will get, it is equivalent to log of s square plus a square minus log of this square root of s plus b. Now what we will do is, here I'll keep this term as it is, and we all know that square root of s plus b is nothing but s plus b raised to half. Now again we'll apply the property of logarithm, which says log a to the power b is b log a, so that will become half log of s plus b. So here this root was raised to half and I brought that half over here. So now this can be the simplest form of this given logarithmic function, and if I try to find out derivative of this, I'll get that derivative in one step. So let's find out the derivative, guys. So here I'll say this derivative of this function of s is, here it's 1 upon s square plus a square into derivative of this, that is 2s, minus half as it is, and derivative of this is 1 upon s plus b. And guys, you can see that I got the answer in one step. So now I got the derivative of this phi of s. Now let's find out the inverse Laplace transform of this phi dash of s. So here I'll say, or I'll directly use the property, that is this property. So inverse Laplace transform of phi of s. So phi of s is my question. So here I'll say, therefore inverse Laplace transform of log of so it is equal to negative 1 upon t into inverse Laplace transform of phi dash of s, that is this value. So that is 2 into now guys, let's find out inverse Laplace transform of each function separately by using the linearity property. So that is, here I'll say it is equal to negative 1 by t, 2 as it is. Now guys, inverse Laplace transform of this s upon s square plus a square is cos of at minus half. Here inverse Laplace transform is 1 upon s plus b is e to the power minus bt, and this is what the value of inverse Laplace transform of this log term. So guys, here we got the answer by using the differentiation of phi of s property and finding the derivative of that phi of s. So keep watching the videos and do share it with your friends so that they can also get the simplest method to solve the sums based on the logarithm or the inverse Laplace transform of logarithmic function. Thank you very much.